Okay, guys, so today we have a quick review on chapter 7, 8, and 9. We start from the sampling distribution, and then the confidence interval, and then the hypothesis testing. Uh, we will start with the first chapter for today, chapter number 7, about the sampling distribution. If you remember, we have two methods. Okay, let me just quickly recap them. Okay, the first of all, the sampling of the sampling. The sampling distribution. Okay, of course, this the sampling distribution for statistic. What that means this distribution is a distribution for a statistic. Maybe the mean, maybe the proportion, maybe the median, maybe the standard deviation. Okay, in our class here, we have just two of them. We have mean and we have proportion. Okay, so we have a sampling distribution for the population mean mu, and the sampling distribution for the sample mean x bar, and sampling distribution for the sample proportion p hat. Okay, we start with the sampling distribution for x bar. If you remember, we said that we have here two things. Okay, if the population is normally distributed, in other words, the population is the shape of the population data, or the data of the population, is normal distribution. Okay, so in this case, x bar, also whatever the sample size is, small or large in this case. So x bar follows the normal distribution with mean mu, which means the same mean of the population, and standard deviation sigma divided by square root of n. Okay, so this is the first thing. This rule for any sample size, small, large, whatever. But if the shape of the population is not known, we don't know it. Okay, here we wanted to say that also x bar is normally distributed with the same mean mu and the sigma divided by square root of n. Okay, this is the standard deviation. We wanted to say that, but to say that we have one condition. You have to have sample size 30 observation or more. So the sample size n should be 30 observation or more. Okay, so we can apply here now something called the central limit theorem, because the central limit theorem say that regardless the shape of the population, if it's normally distributed, it's not normally distributed, is skewed or whatever, okay, if the sample size is 30 observation or more, okay, so the sample mean x bar follows normal distribution with mean mu and standard deviation sigma divided by square root of n. Okay? Okay. This is the first thing about the sampling distribution. Okay. The second one is the proportion, the sampling distribution for the sample proportion, p hat. Okay, and the p hat, if you remember, this is x divided by n. What is x? Number of successes, and the n, of course, we can say sample size, or can say the number of trials. Okay, so this is the estimation for p hat. Okay, so p hat follows normal distribution with the same mean b and standard deviation b 1 minus b divided by n. This is the rule according to the central limit theorem. Okay, but of course we don't know b in most cases, the population proportion, so we use the estimate in this case to calculate the standard deviation here. So we will put here b hat, and here we will put b hat, which means we estimate the proportion from the sample, and in this case we can use it with the central limit theorem. Okay, so this is a summary about the sampling distribution, chapter number 7. Okay, so let's do this question about the sampling distribution. When you have a question like that, first of all, you have to know which statistics I deal with. Is it the mean or the sample mean or the sample proportion? Okay, so according to the National Association of Theater Owners, the average price for a movie in the United States in 2012 was $7.96. Okay, so from this sentence, we can say the average price. So here we are talking about the mean, the average price, mu. Okay, so assume the population standard deviation is 0.5 or 50 cent, and the sample of 30 theaters was randomly selected. What is the probability that the sample mean will be between $7.75 and $8.2? Okay, so here we need to find the probability for what? For the sample mean, x bar. Okay, it's not x. So what that means, we need to find the probability that x bar between 7.75 and 8.2. We need to find this probability. To find this probability, okay, first of all, you have to know what is the distribution of x bar. So first of all, look at the sample size. Is it 30 observation or more or less than 30 and more or less than 30 observation? There's the first thing. Second thing also, do we know the shape of the population or not? Of course, from this scenario, it doesn't tell us anything about the distribution of the average price for the movie in the United States. We don't have this. It doesn't say it's normally distributed or it's doesn't have any information here. So we assume that we don't know it. So we have to have, in this case, the sample size 30 observation or more, so we can apply the central limit theorem, so we can apply the normal distribution, so we can find this probability. Okay, so look at the sample size. The sample size is 30, so it's a good sample size. We can apply now the central limit theorem. Okay, so what that means? That means that x bar follows normal distribution with the same mean for the population, 7.96, okay, But the standard deviation, we need to calculate it because it's a sigma divided by square root of n. So we have to find it. Sigma from the scenario here is 0.5, and we need to divide it by 30. Okay, use your calculator or Excel. So you will find it, it's 0.0191287. I will write it all numbers as you can see. Okay, so this is the standard deviation now. Why I need the standard deviation and the mean? So I can convert x bar to z and then find the probability from the table. Okay, so in this case, after we calculate the standard deviation, we need to convert x bar to z. Okay, so this probability, convert it to z. Okay, so we have 7.75. Of course, z is x bar minus mu sigma divided by square root of n, or the standard error directly. Okay, as you can see here. So x bar for the first one is 7.75 minus the mean is 7.96 divided by the standard error 0.0191287. Okay, this is the first one. The second one the same. So it will be 8.2 minus the average 7.96 divided by the standard error like this. Okay, so now we can find the values for these two equations. So z will be between negative 2.3 and 2.63. Okay, so the situation now we need to find, if we draw z distribution, of course is 0 in the middle because the standard normal distribution z has mean 0 and the standard deviation 1 or variance equal to 1. Okay, so we need to find the area between negative 2.3 and 2.63. Okay, so we need to find this area, this shaded area. Okay, okay, here of course, so we have many ways. We have, actually, we have here 3 ways to solve this problem, but I started with the step by step, the traditional way, okay? Or you can use technology. Well, I will show you, of course, how to find it with technology, of course, but also you have to know the traditional way because this is the background of any Excel function, for example, work with the same manner. Okay, so we need to find the area under this curve between negative 2.3 and the positive 2.63. Okay, don't forget that when we use z table give us the area to the left of the numbers, the area to the left, which means if I need to find the area to, or the table give us the area to the negative 2.3 will be this area. Okay, if I need to find the area to the left, that 2.63 will be this area, whole area, all the way to the negative infinity. Okay, as you can see here. Okay, okay. If you remember, when we, if you return to the chapter number 7, we have some rules. No, sorry, not 7, 6. We have some rules about finding the probability from the normal distribution. Okay, here you need to find the area between 2 points. So in this case, under the curve, you have 2 areas, large area and the small area. Of course, the large area is the green one for 2.63. And the small area for negative 2.3, the red one, okay? And we need the area between these two numbers. So if you subtract the small area from the large area, because the large area contains also this small area. So the remaining will be the area between these two numbers. Okay, we translated it this rule mathematically by this way. So we can rewrite this probability by this way. The probability that z less than 2.63 minus the probability that z less than negative 2.3. So again, we subtract the small area from the large area. So the remaining, okay, or the result will be the area between these 2 points. Okay, of course, we can find these two probabilities from the table. Okay, so let me share with you the table. So the first probability we need to find is the probability that z less than 2.63. If you remember, we need to split this number into two numbers, right? 2.6 and 0.03, right? Where we can find 2.6, we find it on the first column. 2.6 is down here, as you can see. And the 0.03, we can find it at in the first row, 0.3. So the intersection between this row and this column give us the area to the left of 2.63. This area is 9957. Okay, so this is the first one. Same thing for the second probability. We need also to find the probability that z less than negative 2.3. Okay, so here you don't have another numbers or second number after the decimal point. Okay, so you don't need to split the number. You just find negative 2.3 here, okay, under the first column, because after 3 we have 0 actually. So under the second column. So the intersection between them is 0.0107. So you have now the small area and the large area to the left of these two numbers. Okay, now you will subtract the small area from the large area. Okay, so if we return to our question here, so we will subtract 9, we'll subtract 557 minus 0.0107. Use your calculator, so, or Excel 985. So this is the area between negative 2.3 and 2.63, okay, which is the same area for the original distribution. What is the original distribution? The original distribution is this one. For x, if you remember, this is for z, this one for x. Here, our scenario, we have the mean in the middle, 7.96, okay, and we need to find the probability between 7.75 and the 8.2. So this area is equal to this area. Okay, so the idea again, how we can find the probabilities from the normal distribution. Of course, the scenario or the problem is talking about a random variable x or x bar. Okay, and then we convert x or x bar to z, because the same distribution of z will be the same distribution for the original distribution for our variable x or x bar. Okay, so whatever the area you find from z, it's the same area from the original distribution x or x bar. Okay, so this we have now this probability. So the probability between 7.75 and the 8.2 is 98 or 0.985 or 98.5%. Okay, so we can say the probability, the 98.5% is the probability that the average price for the movie or the ticket movie is between 7.75 and 8.2, as you can see here. Okay, 98.5%. So this is the answer of the first part we have here. The second one, the same idea, okay, but we have different probability. Okay, so we have here, and the second one, what is the probability that the sample mean will be less than 7? Okay, or the average price for the movie or the text the ticket movie is less than $7. Okay, so here we need to find the probability that x bar less than $7. Okay, same idea. Can convert x bar to z, so the probability that z less than 7 minus the average 7.96 divided by the standard error 0.0191287. Use your calculator. So we need to find the probability that z less than um, the probability that z less than negative 10. Okay, so if we draw the z distribution, 0 in the middle, negative 10 is here, and we need the area to the left of negative 10 because it's less than, okay? So that means you can find this area directly from the table, okay? Okay, so let's go to the table and look for negative 10 there. Okay, as you can see here, negative 0, negative 0.1, negative blah, 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 blah. The last one is what? Negative 0.34. Of course, you will not find the negative 10 here. Why? Because as you can see here, just to clean this, the maximum, or we can say the minimum number here, in this case, it's a negative 0.39. Okay, negative 0.39, as you can see here. Okay, what is the area to the left of negative 3.49? It's 0.0002, 0002. So it's so close to zero. Okay, also look at here in this small table, negative 3.5 is what? 0.000233. Negative 4, negative 4.5, negative 5. Look, all the number, if you, of course, go further and further, you will find the probability is getting smaller and smaller. What that means? That means any value less than negative 3.49 is equal, the probability is equal to 0. There is no probability in this case. So if you faced something like that, like what we have here, we have negative 10, of course, directly without looking looking at the table, you will find it is equal to 0 directly. It's impossible that the price will be $7 or less than $7. It's impossible in this case. Okay, so this is the answer of the second one. Okay, another I would like to change it to 7.99. Okay, what is the probability that the sample mean will be greater than 7.99? 7.99. So we need to find the probability that x bar greater than 7.99. So again, convert the x bar to z, 7.99 minus the average 7.96 divided by the standard error 0.01 91287. So we need to find the probability that z greater than 0.33. Okay, so we need say 0.33 is here, and we need greater than 0.33. So we need the area to the right of 0.33 under the standard normal curve. Okay, again, don't forget that the table give us the area to the left, not to the right. So if you remember, return again to our rules in chapter number 6. When we have greater than, hmm, we convert this probability to 1 minus the probability that z less than 0.33, if you remember. Okay, the complement rule. Okay, so this probability, we can find it, of course, from the table. This will be this area, and as you know, the entire area under the standard normal curve is 1. So if you know this area and subtract it from 1, so the result or the remaining will be the area to the right in this case. Okay, so from the table, we will find the area to the left of 0.33. So it's a positive number. It's less than 0.33, which means we will divide this number into 0.3 and 0.03. Okay, so 0.3 is here, 0.03 is here. So the intersection between them, let me just clean this quickly. Yep. So the intersection between them is 0.6, yes, 0.6293, 0.6293, okay, 6293. Okay, so now subtract it from 1, so you have the area to the right of 0.33. Okay, let me just do it here quickly on my calculator. So it's 1 minus 0.6293. So it's 0.3707. Okay, so this is uh, the area to the right of 0.33, and it's the same area like this one. This is the original distribution. The mean is 7.96. Okay, we need to find the probability that the average price is greater than 7.99, this area. So this area is 3707. Or we can say this probability is 37.07%. Okay, so this is of course the probability that the average price is higher than 7.99. Okay, okay. So this is the way of getting the probabilities under the normal distribution for the sampling distribution of the sample mean. Okay, okay. Another question, this one about the sampling distribution for the sample proportion. Okay, the second statistic. Okay, here we have the iPhone. We have here the iPhone maker. Apple announces that 25% of iPhone owners use a certain app. Let X be a binary random variable that equals 1 if a random selected iPhone owner uses this particular app and 0 otherwise. A random sample of 100 iPhone owners, okay, uh, um, it's found that 30 of them use the app. Okay, what is the sampling distribution of the sample proportion for the people who use the app in this sample? Okay, so first of all, as I said to you, you have to know what is the statistic I use here or I deal with in this scenario. So as you can see here, we have sample proportion. So this is our statistic, P hat. And the other said to you, P hat is equal to what? Is equal to X divided by N. What is X? The number of successes. What is N? The number of trials or the sample size. So from the scenario here, we have a random sample of 100. So this is N. And from the scenario, we have 30 users or owners of the iPhone uses that app. Okay, so this is X. So the sample proportion is zero point 0.3 in this case. Okay. Okay. The question now is what? What is the sampling distribution of the sample proportion? First of all, do we have here a large sample? Yes, we have. It's 100. It's greater than 30 observation. So we can apply the central limit theorem. Okay? So the sampling distribution is what? Is normal distribution. So B hat follows normal distribution with the same uh, proportion, population proportion, and the standard error P hat 1 minus P hat divided by N under the square root. Okay, so this is the sampling distribution of the sample proportion. Okay, so from this equation, we need to find what the standard error, as you can see here. So the standard error is square root of P hat 1 minus P hat divided by N. Okay, so we have here 0.3, 1 minus 0.3 divided by 100. Okay, so it's 0.0458. So this is the standard error, as you can see. Okay, so is the sample size large enough to state the conclusion? Of course, you will say yes. Okay. Or does it matter? Of course, it's a matter because it matters because we cannot apply the central limit theorem with a small sample size. We have to have large sample size to apply the central limit theorem. So the distribution of the sample proportion is normally distributed in this case. Okay. Okay. So the sample distribution of the sample proportion now, here we have P hat is equal to 0.3, okay? And of course, the standard error is equal to this number. So it's normally distributed, okay? So now we have this question. Is Apple announcement true? Don't forget that Apple says what? 25% of iPhone owners used a certain app. So to check if this claim is true or false, okay, we have to find the probability at 0.25, this proportion, based on the sample we collected, okay, the 100 iPhone owners. Okay, so in this case, that means, as you can see, of course, I explained that here, maybe you have a question like it, no one will explain that to you. That means to check that, you have to find the probability that the sample proportion is greater than 25%. Okay, so we need to find the probability that P hat greater than 0.25, as you can see here. And we will look at this probability. If it's too small, so that means this proportion is likely to happen. Okay, so this announcement is false. But if the probability is large, so in this case, yes, it's true. Okay, so again, we need to convert P hat to Z so we can find what the probability from the normal distribution. So in this case, we will apply this z greater than p hat minus b divided by the standard error. So we have z greater than p hat is 0.25 here in this case minus 0.3 divided by the standard error 0.458. So we need to find the probability that z greater than negative 1.09. Okay, so don't forget that this is greater than, so we use the complement rule. So this 1 minus the probability that z less than negative 1.09. If you would like to know why, again, this is 0, negative 1.09 is negative, 1.09 is here. We need to find the probability for what? For greater than. As you can see here. Okay. Okay. So okay. So in this case, we will go to the table and find the area to the right. Okay. And then we find the area to the we find the area from the left to the left, and then we can subtract it from one, so we have the area to the right in this case. Okay, so go to the table. We need to find the probability that z less than negative 1.09. So we divide this to negative 1 and 0.09. Negative 1 is here, 0.09 is here. So the intersection between this column and this row is 1379. 1379. Okay. Okay. So in this case, we can find the final answer by this way. So it's 1 minus point 1379. Okay, so we have 0.8621, as you can see. Okay, so this is the probability that this proportion greater than 25%. So it's large proportion. So this claim or this percentage or this proportion is true in this case. Okay. Okay. So this was a quick review on chapter number 7. Okay. Chapter number 8. Oh, before we can go to chapter number 8. As I said to you, these steps, the traditional way to find the probabilities, okay? To find these probabilities by technology or Excel function, as we usually do, okay? It's so easy, okay? Let's just return it to the first question we have here, okay? So, as you can see, here we need to find the probability that X bar between 7.75 and 8.2. Okay, so if you would like to use the Excel function without transform X bar to Z or something like that, you just to use these numbers as it. Okay, so in this case, you will use normal dot dist distribution. Okay, and this function needs the value of the value. Okay, of course, our value here, for example, is 7.75. We need the mean. It's 7.96. We need the standard error. Okay, so it's a 0.01912 87, and because it's a cumulative probability, so you have to put true. Okay, so you will apply this function. Don't forget that then function gives you the area to the left. It's like the table. Okay, so to apply this function here, you will apply it twice. Okay, one for 7.75 and another one for 8.2. Okay, so let's go to Excel. Okay, share it with you. Okay, share screen. Mhm. Okay. So if you would like to write the information from the problem here in Excel, it's a good idea. If not, you can directly put the numbers in the function and calculate the probability. I usually like to put the all information. Maybe I need it for another question. Okay, like here we have 1, 2, 3 questions. So maybe I need these numbers again and again. So I like to put them in the Excel sheet. So the information we have here, we have the population mean, right? Let me say population mean. And this population mean is equal to 7.96. Okay. Also we have, let me just increase this a little bit. Okay, like this. Okay. And also we have the standard deviation. It's equal to 0.5. Okay. And we have sample size of 30. So say n is 30. Okay. So don't forget that here you are dealing with the mean, or you need to find the probability for X bar. So don't use SCD, the standard deviation 0.5 directly. This is not the standard error. You need to find the standard error for the mean. And this is equal to sigma divided by square root of n, or the standard deviation divided by square root of n. So you have to find it first, as we did in the equation, in the in the practice here. Okay, so you will divide the standard deviation divided by SQRT. Of course, SQRT, this is the square root function in Excel, and the standard error here is 0.5, like this. So you have the, oh, sorry, should be n 30, as you can see here. So this is the standard error, okay, as you can see here. So it's a 0.5 divided by square root of 30. Okay, now we need to find what the probability that X bar between 7.75, say like this, and here X bar and X bar, okay, and 8.2, 8.2, like this. Okay, so we need to find this probability. So as I said to you, we'll apply the distribution, a normal distribution function. Okay, don't forget, we still follow the same rules for getting the probabilities from the normal distribution. Same idea. What that means, if you need to find here the area between 2 points, so that means you will find the area, the large area, and subtract it from it the small area. Okay, which means you find first the area for 8.2. So you will use norm distribution function, okay, and then the first the area or the large area for 8.2, The mean, as you can see here, just click on the 7.96. So this is the mean. The standard error, not the standard deviation, okay? SCE, and then cumulative, we will select true, okay? Of course, this function now gives you the area to the left of 8.2, but we want to also subtract what the small area from it. So we say minus norm and apply the function again, norm dot distribution, okay? The second mean is 7.75, same mean, same standard error, and then true, okay? So this will be your function now, okay? As you can see. Then enter. So you have 0.985. This is the same result we have here from the table, as you can see, okay? So of course, with the technology, it's so easy. You don't need to do a lot of things. For the second question, when we need to find the probability that X bar is less than 7, okay? I know it's equal to 0, as I said to you, but just more practice. Normal, the distribution. Mhm. The mean is equal to 7. Same population mean, same standard error, and the true, look, gives you this number, okay? This number is 0. This number is 0 because you have E negative 26. What that means? That means after the decimal point, you have 26 zeros. Of course, it's a too tiny, too tiny number. It's close to 0. It's 0. Okay. So in this case, this is the answer. Okay. The third probability is to find the probability that X bar greater than 7.99. So again, we need here the area to the right, not to the left. Okay, so we have to apply the complement rule, 1 minus the probability that X bar less than 7.99. So again, this will be 1 minus the probability that X bar less than 7.99. How we translate it to an Excel function? Same idea. 1 minus and the normal distribution function, the average 7.99, the population mean, the standard error, and the true. So you have the answer as you can see here, 3712. Okay, of course, all the results from Excel is more accurate than what we have from the table. If you remember, I said that to you. Okay, the table, we sometimes we round the numbers so we can deal with the 2 digits after the decimal point, right? But here you don't need to do that, and you will have the accurate probabilities as you can see. Okay. Okay, so let's go back to our exercises. Okay. Okay, now we will talk about the confidence intervals. Okay, for the mean and also for the proportion. Okay, if you remember, quick review like this. We said that the confidence, for example, the 95% confidence interval for the population mean or average mu is X bar plus or minus 1.96 times the standard error. The standard error is equal to the standard deviation divided by square root of n. Okay, this standard deviation, we give it a symbol S, if you remember, S, the sample standard deviation. Okay, so you can estimate the population mean by this confidence interval. So the population mean has now an interval. This interval has lower limit and the upper limit, and all values within this range, we the population mean should be within this range. Maybe or maybe not. If you remember, okay, we said that maybe or maybe not. It's based on the location of X bar under the normal, the sampling distribution of X bar, and of course there is another factors effect on them. Okay, so this is the confidence interval for the population mean. Okay, um, this is for the 95%. Okay, and um, we suppose here n is greater than 30 observation. Okay, what if it's not greater than 30 observation? It's less than 30 observation. Or the other word, uh, here we assume that, let me just correct that quickly. If we assume that we know the population standard deviation sigma, so we can apply this one and use 1.96. What if we don't know sigma? We don't know it. Okay, so as I said to you, we will use S, the sample standard deviation. But in this case, we cannot use 1.96 because 1.96 comes from Z table or Z distribution. Okay, we cannot use Z in this case. We have to use another distribution. We called it T distribution, if you remember, T distribution. Okay, in this case, we have some modifications in this on this confidence interval will be T alpha over 2 n minus 1, and the standard error is S divided by square root of n. Okay, and usually in practice we use the second confidence interval with the red font color here, because if you remember we said what if T, of course T distribution, this distribution depends on the sample size and the degrees of freedom n minus 1, as you can see. And T distribution, it's so similar to the normal distribution except one thing, that it's flatter than the normal distribution because it's the standard error, the standard deviation for it is it's greater than 1. Okay, so in this case, uh, uh, when we increase the sample size, T distribution, this curve becomes closer and closer to the normal distribution according to the central limit theorem. So if you have 30 observation or more than 30 observation, the curve of T distribution approximately similar to the normal distribution. Okay, so in this case, you don't lose the same idea or the using the normal distribution in this case. Okay. Okay, let us apply this here. Suppose we have a pool asks visitors to a website for the number of hours spent observing daily. The pool gets 223 responses one day. The average responses is 3 hours per day. So this is the average response, 3 hours, okay? With a standard deviation 1.5. We need to construct the 95% confidence interval for the average time this website's visitors spent serving the web daily. Assume this day was representative of their visitors in general. Okay, so first of all, we have here what is the sampling distribution of the sample means. What? Of course, we have to ask this question first. Why? First of all, we don't know what is the shape of the population. Is it normal distribution or not? We don't know it. Doesn't say anything here. Okay. Second, we have to look at the sample size. The sample size here is 223. So it's large enough. So we can apply the central limit theorem. Okay. So is the sample size is large enough for the conclusion? Yes. Because we can apply the central limit theorem according to that. Okay, so in this case, we can say the sampling distribution of the sample mean x bar follows normal distribution with mean 3. Oh, sorry, with mean mu, we don't know 3, we don't know mu, and the standard deviation sigma divided by square root of n. Okay, but here we don't know mu. We need to estimate it by a confidence interval. And also, we don't know sigma. Okay? So we have the estimate S 1.5. So we cannot apply the normal distribution here. Because the sample size is too large, and we can apply the central limit theorem here. So this is, we can say, a condition, okay, or assumption we have to check, so we can apply the confidence interval in this case. So because the sample size is large, we can apply the central limit theorem, so we can conclude that the sampling distribution of x bar is normally distributed, and this is the first check you have to make sure that the distribution is normally distributed. After that, you can construct the confidence interval. Okay. Uh, another, for example, suppose the sample size here is less than 30 observation. Okay, less than 30 observation. Okay, and we don't know the shape of the distribution, it's normal distributed or not. So of course we cannot apply the central limit theorem in this case, so we cannot use this confidence interval in this case. Okay, but in this case we can use t instead of the normal distribution, so we can of course construct the confidence interval. The second question is, what is the standard deviation of the sampling distribution in this case? Sometimes we call it the standard error. Okay, so the sampling distribution of the sampling mean, the sampling distribution is the standard error of the sample mean, same thing. So the standard error is, as I said to you, S divided by square root of n. S is 1.5, the sample size is 223. So we can find the standard error for it now. Okay, let me just find it. Yeah, so it's 0.1004. So this is the standard error now. Okay, we need to calculate the 95% confidence interval for the sample mean. As I said to you, we have n 223, we have s 1.5, we have now the standard error 0.1004, we have x bar is equal to 3. Okay, this is of course from the scenario, so we can apply the 95% confidence interval for mu, or for the population mean, x bar plus or minus t alpha over 2 n minus 1, the standard error. Do we have x bar? Yes, we have it. Do we have the standard error? Yes, we have it, but we don't have the t-score, this value. Okay, why? Because we need to calculate here or to know here two things. The confidence level, because we need to construct the 95% confidence interval, so the confidence level is 95%. The second thing is the degrees of freedom, df. It's equal to n minus 1. So we have 2, 2, 3 minus 1. So it's 2, 2, 2. Three twos, as you can see. Okay? Okay. So can we now find the t? Yes, we can find the t from t table. So you can find this from t table. Okay? Let's go to t table. It's here. Okay, so as you can see, for in T table, you have the confidence level up there, the first row, okay, and the degrees of freedom here, first column, as you can see. Okay, so our confidence level is it's a 95%. Okay, this one, and degrees of freedom 222. So where is 222? Of course, you cannot find here 224, 22, right? You have here 100, but look at the last row there, infinity. What that means? That means that any number greater than 100, okay, whatever this number, all these values here still the same, no change. So for 222, the T score is 1.96, as you can see, because this is the column we wanted to use, this one, as you can see. And if you look at these numbers, you will find it's exactly what we have, of course, according to the confidence level, what we have in the normal distribution. Exactly. Okay? Okay. So the T score now is 1.96. So the T alpha over 2 n minus 1 is equal to 1.96. So now you can find the confidence interval. So it's 3 plus or minus 1.96 divided by the standard error 1004. Okay. Now find the margin of error, which means this part. So we have here 0.1978, and then find the upper limit and the lower limit. The upper limit, of course, you add the margin of error to 3, so you will have 3.1978, and the lower limit, you subtract the margin of error from 3, so you will have 2.8022. So this is the 95% confidence interval for the population mean. So we estimate here the population mean that it may be between 2.8022 and 3.1978. Okay, so this is the confidence interval for the population mean. Okay, what about the confidence interval for the population? Yes, for population proportion. Okay, so for the population proportion, the confidence interval like this. For example, the 95% confidence interval for P, the population proportion is P hat plus or minus 1.96 times the standard error. The standard error here is P hat times 1 minus P hat divided by N. So this is the rule we use. To apply this one, you have to make sure of two things. Okay, first of all, the sample is randomly selected. Okay, and n times b is greater than or equal to 15, and the n times 1 minus b also greater than or equal to 15. Okay, so you have to check this first, and then you can apply the confidence interval. Okay, okay, let's do this. Michelin tires would like to estimate the average tire life of its Latitude Tour tire in terms of how many miles it lasts. Determine the sample size needed to. Oh, no, not that, not this question. This question, yeah. Yes. In 2014, consumers reported article titled "The High Cost of Cheap Chicken." The magazine reported that out of 316 chicken breasts bought in randomly selected retail stores throughout the United States, 207 contained E. coli bacteria. Find a 95% confidence interval for the population proportion of chicken breasts in United States retail stores that contains E. coli. Okay, so here we are dealing with the population proportion. We need to estimate this population proportion. Okay, so first of all, we need to find B hat, right? Is X divided by N. X is the number of successes, N is the sample size. So from the scenario, the sample size is 316. And from this random sample, we found what? 207 contains E. coli bacteria, or 200 pieces, or test, for example, 2.7. Okay, so the estimated, the p hat, the sample proportion, 0.655. Okay, now we want to check the conditions. N times B, N here is equal to 316 times B hat 0.655. Of course, will gives you what? 207. What of course, it's greater than 15. What about N times 1 minus B? So it's 316, 1 minus 0.655. You will find it's equal to 109. Okay, so it's greater than 15, so we can conclude that the distribution for the sample proportion is normally distributed according to the central limit theorem. So this is the check. Okay, so now we can apply the confidence interval. P hat plus or minus 1.96 divided by the standard error, but we don't calculate the standard error yet. So in this case, the standard error is square root of P hat 1 minus P hat divided by N. So it's a square root of 0.655 times 1 minus 0.655 divided by 316. 316, like this. Okay, and then the answer is 0.0267. 267. So now we can estimate the or find the confidence interval. So it's 0.6355 plus or minus 1.96 times 0.0267. Okay, so it's 0.655 plus or minus. Find the margin of error. It's 0.5050524. Okay, so now you can find the upper limit and the lower limit. The upper limit is 0.7075 and the lower limit is 0.6026. Okay, so within this range we have the population proportion of the the chicken breasts that contains the E. coli bacteria in this case. Okay? Okay. Next question. Can you conclude that this proportion exceeds 50%? Okay. And to answer on this question, look at the lower limit and the upper limit of the confidence interval. Look at this one. It's 0.60, or we can say 60.26%. And the upper limit, 70.75%. Both are greater than 50%, right? So yes, we can conclude that. Yes, we can conclude that. So yes, we can conclude that. Why? As I said to you, okay, according to the 95% confidence interval limits, okay, both limits are greater than 50%. So this is the justification. Okay. 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 Sounds good. Okay. Another question about Michelin tire. Okay, Michelin tire, Michelin tire. Okay. Sometimes before constructing the confidence interval, we need to know what is the appropriate sample size so I can construct the confidence interval and contain the same confidence level. Okay, so in this case, let me just quick, yeah, I can do this here. We have two formula, one for the mean and one for the population. For the mean, if you would like to estimate or to know the required sample size, you will apply this. N is equal to Z alpha over 2 times the sigma. Of course, it is a square divided by M, and the M here, we call it the margin of error. Okay, so this is the formula we use to estimate the required sample size. Okay, and for P, it is like this. Z alpha over 2 square P 1 minus P divided by M square. Okay, but we have a problem here about B, how we can know the sample size, or we estimate the sample size based on B, and we already wanted to estimate B. We don't know. Okay, so if you remember, we said that if you don't have any information about P, so in this case, you will put P directly equal to 0.5. Otherwise, it will be given in the equation, because it's a given means it's known from the previous studies or something like that. Okay? So these are the two equations we use to know what is the required sample size to construct the confidence interval. Okay? So let's let's return to this equation. Michelin tires would like to estimate the average tire life of its Latitude Tour tire in terms of how many miles it lasts. Determine the sample size needed to construct the 95% confidence interval with a margin of error equal to 2,000 miles. Assume that the standard deviation for the tire life of this particular brand is 8,000 miles. Okay, so as I said to you, here we need to do what? To construct confidence interval, okay, for the mean uh, life of this tire or yes, type of tires, okay. And here we have the margin of error is equal to 1,000, so this is M. Also, we have here the standard deviation of the life tire particular brand is 8,000, so this is sigma 8,000, and we need the sample size to construct what? The 95% confidence interval. So the confidence level is 0.95 or 95%. Okay? So according to that, n should be z square alpha over 2 times sigma square divided by m square. We have m, yes. We have sigma, yes. We have z, no. We need z. Okay. As you know, z for confidence level 95% is equal to 1.96. Okay. Um, Suppose we have different confidence level. For example, 90%, for example. Okay. So in this case, actually, you have a table about the 90%, 90%, and the 95%, and you have these scores for these levels. It's already, because these are the more confidence levels we use in statistics, okay? So you can find them in chapter number 8, okay? Or I will show you now how to find it from the table. It's not hard, okay? So it's like this. I will assume that it's 95%, just to confirm this number, okay? So all you need, something like that. You need to know what is these, between them, we have 0.95 as a probability under the normal curve, okay? So what is the remaining area under the curve now? It's what? 0.05, right? So now the area is is equal to 1. But this area, this is the remaining area is divided by two areas, here and here, right? So when we divide it by 2, so you will have here 0.025 and here 0.025, okay? So now you have the all areas under the curve are defined, as you can see here. Okay, so which one should I find first? As I said to you before, the table gives you the area to the left. So if you know the area to the left, you can find the z as well. So the easier one is to find oops, the area, this area, because we already know it's a 0.025. So you will find the negative value, and this value is symmetrical about 0, so you already have the value anyway. Okay, so if you go to the table, look for the closest number to 0.025. We have the same, the exact number here, and this is the area to the left of negative 1.96, as you can see here. So it's the same idea, okay? So you can do this for any confidence level, not just for this one, okay? So here you have negative 1.96, and also here we have 1.996. Okay, so you already know that Z is 1.96. Okay, okay. Uh, or you can use Excel. Okay, in Excel you can use nor dot inverse dot s dot inverse. Okay, I'm not sure if there is s or not, but we will see that after a while. Okay, and here you will put 1 minus alpha divided by 2. Okay, which means 1 minus 0.05 divided by 2. 1 minus 0.05 divided by 2. Okay, like this. We will see that on Excel after a while. So you can find the z's from the normal distribution like this. Anyway, if you would like to find now the confidence, the required sample size, so it's 1.96 square times 8,000 square divided by 2,000 square. Okay, use your calculator. You will find that is equal to 61.4656. Okay, when we wanted to when we use these equations to find the required sample size, always round the results up, even if you have 0.0000 something. Okay, always round it up. So the required sample size is 62 in this case. Okay, so this would be the answer for this question, how we can find the required sample size to construct a confidence interval based on a specific confidence interval, confidence level in this case. Okay, okay, just let me show you how to find Z from with Excel from the normal distribution. So Excel is here. Okay, so I just said to you, you can use norm inverse. Yes, it's correct. Norm dot s dot inverse. Yep. And here you will put the probability. I just said to you, the probability here will be 1 minus alpha 0.02 0.05 divided by 2, like this, and enter. So look, it's what? 1.9599, which means 1.96, as you can see. Of course, you can do this for any confidence level. Okay, someone can ask me why 0.05. This is the remaining of 95% or 0.95. So this, because again here I can do this table. This is the confidence level. So this is 1 minus the confidence level. So if the confidence level 0.95, so the remaining will be what? 0.05. So because of that, I used here 1 minus 0.05 divided by 2. Suppose you have here 0.99. Okay, so the remaining is what? 0.01. So here when we need to find the z in this case, so you will use norm dot inverse dot s, or this dot s dot inverse, and will be 1 minus 0.01 divided by 2, like this. Okay, so will be 2.575. Okay, so you can do this for any confidence level, as I said to you. For example, suppose 0.82. Huh. So the remaining is 1 minus 0.82, so will be 0.18. Okay, so Z in this case will be norm dot S dot inverse, and you will put here 1 minus 0.18 divided by 2, as you can see here. So will be 1.34. Okay, so this is the idea how we can find these based on the area, as you can see. Okay, okay. So let's go back to our exercises. Okay. Okay. For this one, about the uh, oh yeah, no, this is chapter 8. Okay. So this is okay. Okay. This one. Okay, I think that's all. Yeah, here. Yeah, that's all. Okay. So now we will go to the last chapter about the hypothesis testing. Okay. For the hypothesis testing, if you remember, we have uh, two applications, also one for the mean and the other one for the proportion. Okay. Um, in, in okay, I can do this here. Okay. So if you remember, we have some steps. The first step is check the assumption. Okay. Don't forget what we have also for the mean and for the proportion. Okay. So for the mean, we have to check the assumptions. The assumptions here is the sample is random and the population is normal. These are the assumptions. Okay. Second thing, the null and the alternative hypotheses. Okay, if you remember, we have three cases. If you remember, we have, for example, um, H naught mu is equal to mu naught, H naught mu, okay, sorry, this is the null hypothesis, okay? And the HA, we have three cases, greater than mu naught, or less than mu naught, or not equal mu naught. This is right tailed test. This one is left tailed test. This one is two tailed test. Okay? Why it's important to know the direction of the hypothesis or the test? Because based on the direction, you will know the where you can find the p-value, from the left tail or from the right tail, okay, or both. Okay, okay, very important to know the direction from the beginning. Okay, so according to the hypothesis testing of the mean, we use the test statistic T, and T is equal to x bar minus mu naught divided by S over square root of n. Okay, so this is the test statistic we use. Okay, unfortunately, we cannot use the tables to find the p-values for T distribution because the table doesn't contain all values we can calculate. So the only way to find The p-value is to use Excel or technology, or if you have a calculator that can calculate the p-value from t distribution. Okay, of course, to find the p-value, you need to know the degrees of freedom n minus 1. So important, okay, to know them. Uh, Let me just quickly go back to, yes, uh, I think it's here. Where, part, which part? I think this is, oh yes, here. So here in chapter number 9, the second part, you will find the Excel functions you need to calculate the p-values based on, of course, the direction of the test, if it's left or right or two-tailed uh, two-tailed test. Okay, so as you can see here, if you have a right-tailed test like here, okay, of course here means that the alternative hypothesis is greater than, okay, so you will use t dot distribution dot rt means right tail, okay, and here you will put the value of the test statistic after you calculate it, and then you will put the degrees of freedom here, okay. If you have left-tailed test like this one, which means again the alternative hypothesis is less than. So in this case, you will use different function. It's a t also, but different function. It's a t dot distribution. Here you will put the test statistic value, the degrees of freedom, and the true. Okay, look, there is no true here, but here we already have true. Okay. Uh, for the two-tailed test, which means the alternative hypothesis has not equal sign, which means you have two-tailed, you must use to find the p-value. So you will use t dot distribution dot 2t. 2t here means the two tails. Okay. And again, you put here the test statistic value and the degrees of freedom. Okay. So it's very important to know these three functions so you can find the p-value for the test statistic or the no, the mean hypothesis testing in this case. Okay. Okay. So let's go back to our review. Okay. For the proportion, okay, same idea. You have to check the assumptions. Okay, the assumptions here. First, sample is random. Of course, this will be mentioned in the scenario of the problem, and then don't forget to check this 1 minus b. So 1 minus b greater than 50. Very important to check these assumptions also again. Okay, and here also the null hypothesis p is equal to p naught. This is the null hypothesis. The alternative may be greater than, which means you have right-tailed test, or p less than p naught, which is left-tailed test, or you have not equal, which means two-tailed test. Okay, as you can see, the test statistic is Z P hat minus B naught divided by B naught 1 minus B naught divided by N. Okay, and here it's your option. If you would like to use the table, you can use it. If you would like to use the Excel functions, you can use the Excel functions as well. Okay. Okay. Here, if you have right, if you have, oh, let me show you. This will be better from the slides directly. Where? Here. No, this is the mean. Oh, again. I think this one. Yeah. It's here. Mhm. Here. In this slide and this slide. This one for the table, this one from the Excel function. Okay. So let's start with this one. As you can see here, if you have right-tailed test, which means that the alternative is greater than P naught, okay? So you need to find the probability that Z greater than the test statistic value Z naught. Here, the test statistic value will be positive, okay? Which means you need to find what? The right area of Z naught, okay? So that means you will apply the complement rule. 1 minus the probability that Z less than the value of the test statistic Z naught. And of course, you can find this probability from the table, subtract it from 1, so you have the p-value. Okay? If you have left-tailed test, which means the alternative hypothesis is less than P naught. So as you can see, you will use this probability that Z less than negative Z naught. Of course, the value of the test statistic is negative in this case. Okay, and you can find this probability from the table directly. You don't need to do anything else. If you have two-tailed test, which means the alternative hypothesis is not equal to B, not okay, based on the value of the t-test of the test statistic, positive or negative, you will calculate the b1, the b value. So if it's a positive, okay, so you will apply this one. It's 2 times the probability that Z greater than the value of the test statistic. And again, this probability is 1 minus probability that Z less than Z naught, like the first case we had here. Okay? But if it's a negative, so you have 2 times the probability that Z less than negative Z naught, because in this case it's a negative, and you can find this probability directly from the table, but don't forget to multiply by 2 because it's a two-tailed test. Okay? Or you can use the normal distribution function in Excel, as you can see here. It doesn't erase. I don't know why. Come on. Oh, maybe it's out of charge. No, it's good. Technology. Okay, okay. I change the color and work on this the new color. Let it's a green one or this one. Okay. So if we have right tailed test, okay, so you will use 1 minus nor dot s dot distribution, the value of the test statistic z, and then true. Okay, if it's a left-tailed test, so you will use equal directly the normal distribution function, as you can see here, and the value of the test statistic and the true. If it's a two-tailed test, either CQ based on the value of the test statistic, positive or negative, you will use the function. So if it's a positive, so you will use 2 times 1 minus the normal distribution standard deviation, S distribution, the value of the test statistic, and the true. If it's a negative, so you will use 2 times the normal distribution function, negative z, or the test statistic value, and true. Okay, so these are the Excel functions you wanted to use if you wanted to you need to use if you wanted to find them from Excel. Okay, and again, we after that we compare between the p-value and the significance level. Usually it's a 5%, and we have the rule here. If the p-value less than 0.05, we reject the null hypothesis. If it's greater than 0.05, we don't reject the null hypothesis, and then we comment on uh, this result. Okay. So let's talk about the first example here. A new CFL bulb is claimed to have an average life that exceeds 8,000 hours. So here we're talking about what? Average life, mu. And here, mu naught. Okay? Suppose the average life of a random sample of 36 of new bulbs is 8,120 hours. So this one from the sample, this is the sample size. This is x bar from the sample. And the standard deviation for the life of CFL bulbs is 500 hours. So this is S, the standard deviation. Okay. Does this sample provide enough evidence to support this claim? Use significance level alpha 0.05. Okay. So here first we have to check the assumption. The first one is the sample is random. Do we have a random sample? Yes. It says what? A random sample of 36. So this is the first assumption. Okay. So the sample is random. The second one is what? Huh. It's normal. Is the sampling distribution is normal? I will say yes. Why? Even if you don't know the sample distribution here, it doesn't mention anything here, but the sample size is greater than 30 observation. So you can apply the central limit theorem. So X bar is normally distributed or has a normal distribution in this case. So yeah, this is the we can say the sampling distribution for X bar is normal. Why? Because n greater than 30 observation, so you can apply the central limit here. So this is what the second assumption. All assumptions are met here. Okay. Then the null and the alternative hypotheses. The null hypothesis says what? Mu is equal to 8,000 hours. Okay. Okay. So the question is, does this sample provide enough evidence to support the claim? It doesn't say, does this sample provide enough evidence to, or to say that the CFL bulb is less than 8,000 hours or greater than 8,000 hours. It doesn't say any direction for greater than 8,000 or less than 8,000. So in this case, you assume that this test is two-tailed test because the alternative in this case will be mu not equal to 8,000. So it will be two-tailed test. Okay. Now you calculate the test statistic T, x bar minus mu naught S divided by square root of n, x bar 8,120 minus 8,000 divided by S 500 over square root of 36. Okay, so it's equal to where, oh, let's see it here. So it's 1.44. Okay, and then we need to calculate what the b value. So the b value is based on the direction of the test. This is two-tailed test, right? Oh, wait a minute. I forgot something. Uh, he said that here a new CFL bulb claimed to have an average life that exceeds 8,000, right? Exceeds 8,000. This is the claim. Okay, we need to adjust something here. The claim says that it's exceeds 8,000. So the alternative is greater than 8,000. So this is the claim. Okay, so it's not two-tailed test. It's a right-tailed test in this case. Yeah. Because the claim says what? Exceeds 8,000 hours. Okay, so this, the alternative hypothesis here represent the claim. Yeah, so this is correct now. So the b value should be based on that the test statistic direction here will be this, of course, test to the right-tailed test. So it's right-tailed test. Okay, which means I need to use the right tail to find the b value. Okay, so according to that, we need to find the probability that z greater than z naught, or the probability that z greater than 1.44, which means 1 minus probability that z less than 1.44. Okay, am I right? No, I'm not right. Why? Because this is not z. This should be t, not z. Okay, don't forget that. Mu hypothesis testing, we use t. After a while, you will see p, which means the proportion, we use z. Don't confuse. Okay, so this is not right. The right thing, we use the function, the Excel function to find the p value in this case. Okay, so this is not right. Okay, the right thing is to use the function from Excel. This function will be uh, t dot distribution dot right tail, because this is a right tail test. Okay, and then you will put here the value of the test statistic 1.44 and the degrees of freedom. We didn't calculate the degrees of freedom, so n df is equal to n minus 1. So we have 36 minus 1, so it's 35. Is it 36? Yes, 36. So we have here 35. So from, uh, don't forget equal before it. So from Excel, you can find you can find them. Excel here. So any empty one, so it's equal to T dot distribution, right tail, as you can see here. Put here 1.44 and 35. So the p-value is 0.0799, say 794. That's it. Okay. 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 So now we compare between the p-value and alpha. Alpha significance level 0.05. Huh. Compare between them. Which one is greater? The p-value. So the p-value is greater than alpha. Huh. If you return to our table, uh, talking about the rule of the p-value, huh, in this case, our decision is don't reject H naught. Okay, so what that means, we cannot reject this one, but we can reject this one. So what that means, don't forget the alternative hypothesis is about what? The claim. So we can answer now on that question. Does this sample provide enough evidence to support the claim? Of course not, because we reject this one. So that of course, based on the test, okay. So this data doesn't support, or this sample doesn't support what the claim. So we can say now we can say sample directly, okay? The sample doesn't uh, provide enough evidence to support the claim. Okay, so we are done from this hypothesis testing, as you can see. Okay, another one. The mean data used for smartphones users is claimed to be 1.8 giga per month. Suppose data use is recorded for 49 randomly selected smartphone users and the average use, the mean, the average, so we are talking about mu, the average use is found to be 1.86. So from the sample, we found the X bar, okay? Assume that the population standard deviation is 0.2. Does this sample provide enough evidence to support this claim? Use significance level alpha 0.05. Okay, so again, is this sample a random sample? Yes, because it says what? 49 randomly selected smartphone, so the sample is random. Okay, does the is the distribution of the sampling distribution of the sample mean is normally distributed or not? Okay, okay, let us look at any information about the population. No, nothing about the shape of the population, but we have a sample size 49, greater than 30 observation. So we can apply the central limit theorem. So the distribution of X bar is normally distributed. So this is the first one. The second one, we say the distribution of X bar is normal according to the central limit theorem. Okay. Now the null and the alternative hypotheses. Okay. So the mean data used for smart users is claimed to be mu equal to 1.8. So this is the null hypothesis. Okay. Does this sample provide enough evidence to support this claim? Doesn't say it's maybe it's greater than 1.8, less than 1.8. Doesn't say that. So we suppose this distribution is two-tailed test. Okay. Now calculate the test statistic. T x bar minus mu naught s divided by square root of n. So we have x bar 1.86 minus 1.8, the standard error 0.2 divided by square root of 49. So the value of the test statistic is, let me just find it here, 2.1. 2.1, it's a positive, okay? Okay, now the p-value. This is two-tailed test, okay? And the value for the test statistic is positive, okay? Okay, so we will use T distribution two-tail and the value 2.1 and degrees of freedom we didn't calculate it, so df is n minus 1. We have here 49 minus 1, so will be 48. 40 like this. Okay, so we will go to Excel to calculate the p-value. So it's a t dot distribution to tail 2.2 and 48. So it's equal to, the p-value is equal to 0.041. 0.041. Okay, now compare between the p-value. Let me just write it down here again. And alpha 0.05, the significance level. Okay. Oh, sorry. I put greater than. Sorry. So according to this comparison, we can find the p-value is less than alpha, right? The p-value is less than alpha. So according to this, the decision is reject H naught. What that means, we will reject this. Don't forget, this is what the claim, right? This is the claim. So we will reject it and accept what the alternative. We accept this one now. Okay, so we rejected the null hypothesis and accepted the alternative, which means uh, the mean data used for a smartphone is not equal to 1.8 giga per month, maybe less, maybe more. Okay, so does this sample provide enough evidence to support this claim? We will say, of course, what? No, in this case, because we rejected the claim. So this data doesn't support what the claim. So the sample doesn't provide enough evidence to support the claim. Okay, so this is the answer of that one. Okay, okay. Last question. I know it's a lot for today, but it's a review and must be like this. Sorry about that. Come on, is there anyone? Should be larger or something like that. Result is better. Okay, so now we have the 95, the 49 students in a class at the University of Florida made blended evaluations of pairs of cola drinks. For the 49 comparisons of Coke and Pepsi, Coke was preferred 29 times. In the population that this sample represents, is this strong evidence that a majority prefers one of the drinks use significance level alpha 0.05. Okay. Okay. So it looks like here we are talking about what? Huh, the proportion, right? Here you have to evaluate your preference. Do you like Coke or Pepsi? Yes or no? Okay, so you have here just two answers on this question. Okay, so we are dealing with the proportion here. Okay, we wanted to, in this case, we wanted to check the assumptions. First one, does or is the sample random? Okay, look at here. In the population that this sample represents in this evidence, it doesn't say it's randomly selected. Okay, so we will assume that it's a randomly selected. Okay, we assume that 49 students in a class. It said a 49 in a class at the university. No, it's not random. It's not random. It's just one class at that university. They evaluate the Pepsi and the cola preferences, so it's not random. Okay. Okay, so the sample is not random. Okay. Okay. The second thing, the central limit theorem for the proportion. Do we have large sample? Yes, we have 49. Okay, it's a large sample. So we have to check that n times b and n1 minus b. Okay, but first we have to calculate p hat. Okay, so p hat is equal to x divided by n. X here is 29 divided by 49. So it's equal to 0.5. 918. Okay, okay. Of course, if you multiply n times b hat, it will gives you the 29. The more important thing is n times 1 minus b hat. So it's 49 times 1 minus 0.5918. Okay, so this one gives us 20. Okay, so both are greater than 15. So we can apply the central limit theorem. So the distribution of B hat is normal. Okay, okay. So we can complete this test. Okay, even if we know that the sample is not random, just for practice. Okay, so here we wanted to check what is this strong if the majority prefers one of the traits, which means if the, the, the majority doesn't prefer specific one, so will be 50-50, right? 50% to 50%. So in this case, the null hypothesis P is equal to 0.5, which means if this P for the cock, so it's okay. So the other one is also 50%. Or H naught, HA, P is greater than 0.5, which means maybe some the people or the majority prefers one drink over another. Okay, in this case. So this is the null and the alternative hypothesis. The test statistic will be Z P hat minus B naught divided by square root of P naught 1 minus B naught divided by N. So P hat is equal to 0.5918 minus B naught 0.5 divided by zero point 0.5 times 0.5 divided by N 49. So it's equal to 1.286. Okay. Okay. Let me just quickly check that again. Equal to 0.5918 minus 0.5. Okay. And this one is the square root of 0.5 times 5 times 49. So it's equal to this, like this. Point 5 dot 0.5 divided by 49. Oh, divided by 4. Yep, that's correct. Yeah. Okay, let's continue. Okay, so now we have here the alternative hypothesis is greater than, which means we need to use the left tail to find the B value. Okay, it's right tailed test. Okay, so in this case, the probability or the B value is the probability that Z greater than 1.86, which is 1 minus the probability that Z less than 1.286. Okay, Of course, we need to round the 1.286 to 1.29 so we can use the table. Okay, but of course, if you use the Excel, you don't need to round anything. Okay, so in this case, it's 1 minus, and we will go to the table. We need the probability that z less than 1.29, right? So it's 1.2.09. 1.2 is here, 0.09 is there. So it's a 90-15. So we have here 90-15. Okay, so we will have 1 minus 0.9015. So we have 0.0985. 0.0985. Okay, so we will now compare between the p-value and the significance level alpha 0.05. Of course, the p-value is greater than 0.05. So what that means? Huh? What that means? We don't reject the null hypothesis. So don't reject the null hypothesis. Okay, so we don't reject this, and of course reject what the alternative hypothesis in this case. Okay, so what that means? Huh? We return to the question. Is this strong evidence that the majority prefers one of the drinks? Of course, we will say what? No, in this case, because the sample doesn't provide any preferences for the alternative hypothesis in this case. Okay, so we'll say no. There is no strong evidence we can say not enough evidence to support that the majority prefers one of the drinks. Okay, something like that. Okay, of course, the final conclusion you can write it by your own words, doesn't like me or something like it. Okay, so this is the end of our review. I hope this summarized a lot of things about chapter 7, 8, and 9, the sampling distribution, the confidence interval, and the hypothesis testing for the mean and the proportion. Okay, guys.